Alright, we're making an attempt to check the time base here. And what's going on at the moment is that I am set at 0.5 volts per division. 0.5 seconds per division. There are 10 divisions across the screen, so that would be a 5-second sweep. If I'm running at 0.2 hertz, it's going to take me 5 seconds to get across that screen, and I've attempted to give a 0.2 hertz signal here, and we are sweeping across the screen every 5 seconds. Alright. It's kind of slow, and it's really hard to generate any kind of a signal that's meaningful here, but we're going to turn up to 0.2 seconds per division. We're going to increase our sweep to 0.5. Okay, we are running at 0.2 seconds per division. We have a 0.5 hertz signal coming on there, and we're sweeping across the screen about every 2 seconds. We see one cycle. Let's try and turn the time base up again. We are now on 0.1 seconds per division, so it'd be 1 second for a sweep, and we are going to turn ourselves up, and we are getting about one cycle across the screen in a second. Okay, we have our time base right now set up for 0.1 seconds per division, and we are running a 10 hertz signal from our signal generator up here. And what we are seeing is that we're getting one cycle in every division. So we are getting 10 hertz in 10 divisions, which would be 1 second, so you would expect that. Alright, let's go to 0.05 seconds per division. That would mean that we would have, at 10 hertz, we would have one cycle in 2 divisions. And we in fact have one cycle in 2 divisions. Alright, we are now running 50 hertz. We are at 2 milliseconds per division. We've got 10 divisions. That's 20 milliseconds. 20 milliseconds is 0.02 seconds per cycle, which would be 50 hertz. Okay, if we were to increase by a factor of 10, we are now running 500 hertz, and at 500 hertz we should see that we complete a cycle in 1 division, and we are. Down again, we're at 1 millisecond per division. We are right now running we are running 500 hertz, but we are going to change that. We're going to go to 100. Right, there's 100 hertz. We are running 1 cycle in 10 divisions at 1 millisecond per division. 1 millisecond times 10 would be 0.01 seconds, and that would be a 100th of a second, or 100 hertz. Alright, we can pick that up by a factor of 10, and we would see that we are now doing a cycle in a division, which is what we'd expect at 100. We're now running 1000 hertz. We are at 1 millisecond per division. So 1,000th of a second per cycle in one division, that's 1,000 hertz. Exactly what we predicted. Okay, ratchet it down again. We are now at 0.5 milliseconds per division. So it's going to take two divisions to get that 1,000th of a second. So there we are, one cycle in 2 divisions. There's your 1,000 hertz. All right, let's take ourselves, oops, to 0.2 milliseconds per division. 0.2 milliseconds per division. We'd like to be, let's put this at 500 hertz. All right, we're running at 500 hertz. We see that we complete one cycle in 10 divisions at 0.2 milliseconds per division. 0.2 milliseconds times 10 would be 2 milliseconds for that one cycle, 2 milliseconds, which would be 500 hertz. If I was to kick this up by a factor of 10 and drop it back down to 1,000, alright, that's essentially 1,000. We're seeing 2 cycles in 10 divisions. I drop this down to 0.1 millisecond per division times 10 division, that's 1 millisecond, one cycle, 1,000 hertz. Alright, 50 microseconds per division. Forgive me that little cycle or two. There's 2,000 hertz. We are completing one cycle in 10 divisions, and that's at 50 microseconds. Okay. 20 microseconds per division. 5,000 hertz. 5,000 hertz, 20 microseconds per division, 10 divisions, one cycle. Alright. We are now going to take ourselves down again. We are now at 10 microseconds per division. Close enough. 10,000 hertz, 10 divisions, one cycle. Right there. Okay. Take ourselves down another. We are now running 5 microseconds per division. And we're going to kick our frequency up to 20,000 hertz. 20,000 hertz. And we see that we complete one cycle in 10 divisions. That's at 5 microseconds per division. 2 microseconds per division. And alright, there's 50,000. One cycle in 10 divisions, and that's at 2 microseconds per division. So 20 microseconds for the 10, 20 microseconds for the one sweep. That's going to wind up being 50,000 hertz. Alright, we're going to take ourselves down another. We are now at 1 microsecond per division, and we are going to kick ourselves up to 100,000 hertz. Alright, there we are, 100,000 hertz, and we see the one cycle in 10 divisions. Okay. Whoops. 0.5 microseconds per division. We're going to go to 200,000 hertz. Alright, there's 200,000. One cycle in 10 divisions. 0.2 microseconds per division. 500,000 hertz, and we see that we complete one cycle in 10 divisions. And then last 0.1 microseconds per division. We're going to turn ourselves up to 1 megahertz. And there we are. 1 megahertz. 1 megahertz. 1 cycle and 10 divisions. So there you have it. We've gone from end to end, and we've shown that our time base has been accurate for the sweep across the screen. Now, one last check I'd like to do, and that's to put ourselves on ×10 magnification. And we are going to kick ourselves up all the way. Alright, I am right now at the lowest level that I can go, and that's 0.1 microseconds per division, and I've turned the magnifier dial all the way to the right, which means I am now expanded ×10. Alright, once again we have 20 megahertz coming out of our generator, which is a 20 megahertz generator maximum. And we see at 0.1 microseconds per division ×10, we see 1, 2. We see 2 cycles. Two full cycles, and that would be 20 megahertz. Okay, the time base has been tested. We've tested the vertical gain switches. We've taken you through all of the basics of the scope. This is a very nice scope. Whoever gets it is going to get a nice bench unit. Good luck.